morning, everybody. My name is Gaurav Chaudhary. I'm assistant professor in IT department at AKGEC Engineering College, Ghaziabad. Today, I will be discussing on the topic of clustering and K-means clustering. So, to begin with, we first need to know that what is high dimensional data, because in respect to clustering, the clustering acts on your high dimensional data. So the high dimensional data is a data which is spread out in many dimensions. So given a cloud of data points, you want to understand its structure, because your data points, they are spread out in many of the dimensions, and because it is spread out in many of the dimensions, we don't know its structure. So our basic idea is that we want to understand its structure given the high dimensional nature of the data. So there are many methods when it comes to high dimensional data. There are many methods to understand the structure of the data. So here the highlight is of the today's lecture is on clustering, but there are also dimensionality reduction techniques which are applied on high dimensional data to understand the structure of the data. But today we are discussing on the topic of clustering. Then apart from high dimensional data, just to mention, there are graph data, there are infinite data, and then there are machine learning techniques which are applicable on the data, and then we have got apps also. So these all different kinds of data or different kinds of techniques, they all are with respect to the nature of the data. Now coming to the problem of clustering. So what is the problem of clustering? We have already said that we want to know the structure of the data. So given a set of points and with the notion of distance between the points, we have to group the points into clusters. So because we are grouping the points into clusters, and this process is called as clustering. And while doing clustering, we have to take into account that the members of cluster are close or similar to each other, and members of different clusters are dissimilar. So these 2 points you have to keep in mind. And usually what happens in the clustering process is that points are in a high dimensional space, and similarity is defined using a distance measure. So the similarity of the points is defined using a distance measure. The distance measure can be your Euclidean distance, it can be a cosine distance, Descartes similarity, edit distance, etc. So here basically we will be talking about the Euclidean distance, and we will also consider the case where we have the non-Euclidean case. So this is the example of data points, and here we are trying to get the idea of what we understand by the term cluster. So we have got a cloud of data points, and we are actually grouping the points into various clusters. And while doing so, there may be the case that some points are very far away from the many clusters that we are going to form, and so those points will be called as outliers, because they are not part of any of the cluster. Or if we try to make the outliers to be a part of the cluster, then it affects the distribution of the data. So as a pre-processing step, we generally what we do is we remove the outliers. When we process a large data set, we generally remove the outliers as a pre-processing step. So these are the cluster 1, these are the another 2 clusters. And so this slide depicts the difference between the clusters which are formed using the data points and the outliers. So clustering is a hard problem. So when we say it is a hard problem, so it is computationally intensive problem. So it requires a good amount of computation time as well as computational resource to do clustering on a given set of high dimensional data set. So this is another picture depicting clustering of the data points, which is and we are using different colors to denote the different clusters which are formed from the data points. So when we talk about high dimensional data, we should also know we should also know the term of the curse of dimensionality. So curse of dimensionality is that it is a kind of constraint on the data points that we are trying to cluster. It is the characteristics of the data set that we should keep in mind before we proceed on to do the clustering of the data points. So one of the manifestation or one of the characteristic of the curse is that all the pairs of points are equally far away from one another. So because all the points are equally far away from one another, so we will have it will be hard to cluster the points into clusters. And another manifestation is that almost any two vectors are almost orthogonal. So that means that for example, in some dimension we have got a set of points, and we have got a vector for those set of points, and in some another dimension we have got a set of points, and we have got another vector for those set of points. And then normally what will happen is, in a high dimensional data, the two vectors will be almost orthogonal. So when we say the pair of points will be almost equally far away from one another, or the pair of, or the two vectors representing the set of points in different dimensions will be almost orthogonal. So this is the characteristic of high dimensional data, which makes it difficult to understand the structure of the data. Here we are trying to do the clustering of the data to understand the structure of the data. Now coming to methods of clustering. So we have got two methods of clustering. One is your hierarchical agglomerative clustering, and another is point assignment. So in hierarchical clustering, what we do is we initially take each point as a cluster by itself. So each point is a cluster by itself, and then we repeatedly combine the nearest clusters based on some criteria, and we form the resultant clusters. And whereas in point assignment, what we do is we initially maintain a set of clusters, and when the new points come, we place the points into their nearest cluster. So here we will be discussing mainly on the hierarchical clustering. These are the two types of clustering, and we will go into the details of hierarchical clustering in the coming slides. So for hierarchical clustering, there are two important questions which we need to take into account. One is that how do you determine the nearness of clusters? So how you will determine the nearness of clusters for putting the forming the updating the clusters and forming the new clusters out of the original clusters. So, and then how do you represent a cluster of more than one point? This is another point. These are the two questions which we have to consider while we do clustering. So because we have said the hierarchical clustering, initially we say that each point is a cluster by itself. But what we do when we have a we have got, for example, in an initial cluster we have got more than one point. That can be also be the case. So we will be delving on these two issues in the coming slides. Now the key problem is, as you build clusters, how do you represent the location of each cluster to tell which pair of clusters is closest? So one thing is, because you are going to update the clusters, so that will be based on the location of the clusters. And then how do you represent the location of each cluster? That is your key problem. So we will be considering the two cases of assigning the location to each cluster. One is the Euclidean case and one is the non-Euclidean case. We will see the non-Euclidean case in the coming slide. In the Euclidean case, what we do is we take each cluster has a centroid. So each cluster, by centroid we mean the average of its points. And then we measure the intercluster distances by the distances of centroids. So here we have the notion of average of its points, which is the important, which is the main point to consider when we consider the Euclidean case. We have the notion of average of its points, which is called as the centroid of the points, and hence the centroid of the cluster. So suppose initially this shows an example of forming of clusters from two clusters. Both are the examples of forming of a cluster from two clusters. So in this, for example, the cluster on the right hand side of the slide, there we can see we have got 2 points, 0 0 and 1 1 2. So these two are the points, and we will find the centroid of these 2 points to be say 1 comma 1, and we have got another cluster which has got point say 2 comma 1, and so the centroid of 1 comma 1 as well as 2 comma 1 will be 1.5 and 1.5. So this is how we are going to form the clusters. We are going to update the clusters in the case of hierarchical clustering. And this is the pair of clusters on the left hand side is also similar to the it is similar to the way we have formed the clusters in the figure which is shown in the right hand side of the slide. So what we do in the non-Euclidean case, we have seen that we have the notion of average of points in the case of Euclidean case, but but here when we talk about locations of the clusters, we can only talk about the points themselves. We cannot talk about the average of the points in the non-Euclidean case. So there is no average of 2 points. So in this approach 1, we have the notion of clusteroid. There we had the notion of centroid. Here we have got the notion of clusteroid. So the clusteroid is the point closest to other points. So treat clusteroid as if it was centroid when computing intercluster distances. So we will treat the clusteroid as if it were centroid, but we will not have the notion of the average of points, which is the centroid of the points in the non-Euclidean case. So by closest point, now what are the possible meanings? Because we have we have to compute the intercluster distances. So by when we are treating the clusteroid as if it were a centroid, we should have a way of computing the intercluster distances. So here the possible meanings of intercluster distances are your one, it can be smallest maximum distance to the other points, or it can be smallest average distance to other points, or it can be smallest sum of squares of distance to other points, or it can be any other kind of distance to the other points from that point. So your closest point can be anything. It need not be it need not be just be a straight line. It can have different meanings. So this is how you will do your hierarchical clustering. So now coming to the topic of K-means clustering. Now in K-means clustering, what we do is we have to select the value for the K, which is the number of, which denotes the number of clusters, and we have to update the centroid. We have to update the mean or the average of the points which are there in each and every clusters as the clusters are updated. So here the main point is how do you select K, which is the, what is the right value of K to be selected for doing K-means clustering. So we will see that in K-means algorithm, first of all, it assumes Euclidean space or distance. So we start by picking some K, which is the number of clusters, and then we initialize clusters, picking 1 point per cluster. So once we have selected we have picked some value of K for the number of clusters, we will initialize clusters by picking 1 point per cluster. So for example, we will pick 1 point at random, and then we'll pick the K minus 1 other points, such as which are as far as possible from the previous points for each and every cluster. So we have selected some value of, we have picked some value of K, and there is a way of determining the right number of K for the K-means algorithm, which we will see. But initially we can have a rough idea also about how to pick the K, which we will also see in the coming slides. So how do you pick initially how do you pick the right number of how do you pick the some value of K on which you can verify whether that value of K is correct for the convergence of the points which are there in all the clusters. So we will see how do you populate the clusters. So for each point, we place it in the cluster whose current centroid it is nearest. So initially we have got some cluster, we have picked some value of cluster, and then we will add points to that cluster, to the cluster whose current centroid it is nearest to. We will add a point to the cluster. We have got the centroid of the cluster, and we will add the point to that cluster to which the distance to that distance to the centroid of that cluster is nearest to, for each point. After all points are assigned to all the clusters, we will update the locations of the centroids of the K clusters. So when we update the locations of centroids of the K clusters, what happens is we will have to you will see that the location of your centroid will move. So it will change. Your location of the centroid of the K cluster will change. So because it changes, what you have to do is you have to reassign all the points to their closest centroid. The step which we were doing in the process which we were doing in the first step, we have to do it in the third step also after updating the centroids. So because we are again moving the points closest to the centroid, there will be the case that the points will move between the clusters because the centroids have been updated. So we will see the see this steps in the diagrams also. Diagrammatically, we will see the steps, and we will understand how the clusters are formed in the coming slides. And then we have to repeat step 2 and 3 until convergence. So the convergence will be when the points don't move between clusters and the centroids stabilize. So your centroids will stabilize and the points will not move between the clusters. When you will update the clusters, your convergence will be when your last value of centroid will be the same as the just previous value of the centroid. That will be your convergence, and in that case your centroid will stabilize because your previous and the next centroid value is same of the clusters, and when it is same, your points will not move between the clusters. So this is how you will populate the clusters. So this we will see diagrammatically. So in diagrammatically, so again we have got some set of points. So we will pick some value of k because we are doing k-means clustering. So we will pick some value of k, and here we pick the value of k to be 2. So here the x denotes the data point, and the square encompassing the data point denotes the centroid of those set of points. So here we have picked the value of k to be 2. So the pink square is the centroid for the set of points in the first oval, which is the pink oval, and the purple square is the centroid value of the blue oval, which is the centroid for the points which are there in the blue oval. So this is how we are going to go about clustering. And then after picking the value of k of the initial clusters, we will assign points which are closest to the centroid value of the cluster. So here now your movement of points between the clusters will begin. Why? Because your though we have picked the value of k to be 2 and we have got 2 clusters, but we can see that the points which are there at the bottom of the blue oval, the data points which are there at the bottom of the blue oval, they are closest to the centroid which is there in the pink cluster. They are not closest to the centroid of their own cluster. So your points will be reassigned and they will be moved between the clusters. So one of the points at the bottom of the blue oval, it will go into the cluster, pink cluster, and it will become a part of the pink cluster. So once it becomes a part of the pink cluster, your centroid value of the pink cluster will change. So because your centroid value of the pink cluster changes, we will update the centroid value of the pink cluster, and your centroid will shift towards the left of the pink oval, and it will become the new centroid for the pink cluster because of the movement of one point from the blue oval to the pink oval. So again, then we see that because of the movement of the centroid, your data points which were there in the blue oval, they have again come closer to the centroid. Then to the centroid in the pink oval, then they were uh, then their distance to from the blue centroid of the then their distance of the centroid from the blue oval. So because of the updation of the centroids, there may be the case that more points will move between the clusters, and in this case we are seeing that two more points have come out of the blue oval, and they have now they are now in the process of becoming part of the pink oval. So again your clusters are updated. So this is the iterative process which we talked about in the previous slide. This is step in 2 and 3, which we are iterating again and again till we get a convergence, till the centroid values does not change and the points between the clusters do not move. So having seen the way of uh, converging the data points, converging the shape of the clusters, now we come to the topic of how to get the right k value. What will be the right k value? We have picked some value of k in the beginning for our k-means clustering, but is that value of k right? What should be the right k of value? So the general method is that we have to try different values of k, and then we have to look at the change in the average distance to the centroid as k increases. So your average distance to the centroid as k increases, this is the parameter which we have to look for when we have to select the right value of k. So the average falls rapidly until the right k, then changes little. So in this plot, your the y-axis, it shows the average distance to the centroid, and your x-axis gives the number of k, and the best value of uh, K is when your K changes very little. So your slope has to be almost of less degree. So then your change will be very little. So average falls, the average distance to centroid as K increases, your average will fall rapidly until the right K, then changes little. So when it falls rapidly until the right K, and when it becomes almost constant, then we can say that we have got the right value of K, or which is the number of clusters which should be formed for the given data points. So this is just as I talked about how we should go about picking the value of K. We have seen after we have picked the value of K, we have seen in the previous slide to how to verify whether we have got the right value of K. But I also said that I will be giving I will be discussing on the idea to guess about picking the value, or how to pick pick the value of K. So if we pick few clusters, you may pick initially few clusters, lesser number of lesser value of K, or you may pick initially a higher value of K. So if you will pick lesser value of K, you will see that there are many long distances to the centroid for that cluster. If you pick a low value of K, and if you pick a just right value of K, you will find that the distances to the centroid are rather short. So in these three clusters, you will notice that the centroid is almost uniformly distant from all the points, and the distances are rather short. So this is how we will make some initial guess for picking the value of K. And for verifying the value of K, we have to we can verify how to get the right value of K. We have to see that the average distance to the centroid, it becomes constant, and then we can be sure of getting the right value of K. So this completes my topic of clustering, the types of clustering, and K-means clustering. Thank you.